Okay, welcome back everybody. You're still with me, good to know. Okay, continuing on with this example, explain two different ways to evaluate f divided by g at 3. Okay, so explain, you could use f at 3 divided by g at 3, which means you would substitute 3 in for x in f of x, like go 2 bracket 3 squared minus 13 times 2 minus 7 all over 2 bracket 3 plus 1. That would be one way to do it. Or you could use the f over g combined function. We already determined the quotient function at 3, where you take x minus 7 and sub in 3. Which one's less work? Well, definitely this one. So let's use that one to calculate now f divided by g at 3. So that would end up equaling -4, and there we go. There's our answer. All right, next page. Okay, example number 3. Consider the functions f of x equals 2x over x minus 1 and g of x equals x over x minus 3. State the domains of f and g. Okay, so for f, we're looking at this function here. We could graph that on the calculator, but sometimes it's a lot easier just to do it manually to get some of these values to figure out the domain. Now, domain, if you're looking at what possible values of x are there, it's easier to think of it as what values of x are not possible, and then it can be that, it can't be that, and it can be anything else. So, in math, you can't divide by 0, you can't square root a negative number in the real numbers. So we have dividing by x minus 1 going on. So guess what? X minus 1, if we're going to stay within our math laws, can't divide by 0, or cannot equal 0, and therefore x cannot equal 1. There's a restriction on our domain. Any other number would be possible. So to write that for f, our domain would be x such that x is an element of the reals, every other number, but it cannot equal 1. There we go. Same idea with g of x. You guys try that, pause your video, and see if we get the same answer. Okay, so did you also get for the domain x such that x is an element of the reals and x cannot equal 3? So you set the denominator equal to 0, solve for x. Okay, part B. Evaluate 3fg at 2. Okay, this is going back to the last lesson. You'll notice fg inside. If you recall, that is the same thing as going f times g of x. And in this case, it's not x, it's 2. So we're going f at 2, g at 2. Now that 3 in front has to be multiplied by everything that follows. So we're going to write 3, and then I'm going to put some square brackets around the f at 2 and g at 2. So we're going to work on what's inside those square brackets first and then multiply by 3 afterwards. Okay, so let's get this set up. We are going to write 3, okay, f at 2. So we're going to take our f function, 2x over x minus 1. Everywhere you see an x, throw some brackets. So 2 times brackets, and brackets minus 1 in the denominator. And what we're going to do then is put in our new x value of 2. There we go, 2 goes in for x. Then we have times g at 2. Okay, I'm just going to throw some brackets around that, and then brackets. So g at 2, here's our function. Okay, everywhere there's x again, we're going to put some brackets to show substituting in. And we're replacing x with 2. So 2 on top, 2 minus 3 in the denominator. Okay, we're going to simplify this. You can use your calculator as well, but it's sometimes less complicated just to do it manually. 2 times 2 on top here is 4, over 2 minus 1 is 1. And with the other, let's remember our square brackets. With the other function, g at 2 is going to be 2 on top over 2 minus 3, which is -1. Okay, simplifying that, we would have, this would be 4 times -2, which is -8. Okay, and then 3 times -8 is equal to -24. There's our answer. Part C, write an expression in simplest form for f plus g of x. State any restrictions on x. Okay, so f of x, let's just scroll that back up. So if you recall, that is the same thing as saying f of x plus g of x. So let's replace f of x with what it equals, 2x over x minus 1, and replace g of x with what it equals, x over x minus 3. Okay, I'm going to scroll down now so we can see that better. All right, there's our two functions. And it says simplest form. If it hadn't have said that, we'd be done. But simplest form, what they want us to do is they want us to continue and add these two functions together. All right, so to do that, or it's like adding two fractions, we need a common denominator. Okay, so I'm going to make this big fraction now. Our common denominator has to include both of these factors. So x minus 1 and x minus 3 would be our lowest common denominator. Now, because of that, we need to analyze, I multiplied, therefore, this first factor here by x minus 3 to get what I have here. And then I multiplied the numerator. I'll have to multiply the numerator also by x minus 3. Okay, looking at the second factor, to get our lowest common denominator that we want, we'd want to multiply this by x minus 1, and therefore multiply the numerator by x minus 1 as well. It's like multiplying by a special case of 1. You don't change the value, but we do change what it looks like. Okay, so now we would have, in the numerator here, we have this 2x times x minus 3. Do not multiply that out yet, okay? We're going to keep it just like that because mistakes can happen essentially with this positive sign. If it was negative, anyways, I've seen lots of mistakes happen, so let's just keep it like this first. If this was a negative sign, people forget to multiply it through, that's why. All right, so now we're going to simplify this. We would have 2x squared minus 6x. Now we multiply that part out, so plus x squared minus x. Okay. Denominator, do not multiply that out, just keep it as two separate factors. Okay, collect any like terms we have in the numerator. 2x squared plus x squared is 3x squared. Negative 6x minus x is going to be negative 7x. Denominator, once again, stays the same. Okay, looks good. That's pretty simple. We've joined the two fractions up into one fraction. And then finally, they also ask, well, let's read the question, make sure we've answered it. We have an expression in simplest form. Yay, done. State any restrictions on x. Okay, restrictions on x can't divide by 0. So let's take each of our factors in the denominator, and if it hadn't have been factored, we'd have to still factor it. And we set each factor basically cannot equal 0. When we do that, solve for x, we find out x cannot equal 1 and x cannot equal 3. There's our restrictions. Okay, part D, write an expression in simplest form for f divided by g of x. Okay, so once again, we rewrite that as the alternate form. So f of x divided by g of x. Okay, our two functions were, let's scroll up. Our two functions were 2x over x minus 1. And I'm about to put divide, and I could draw the big line like this and then put g of x underneath. But you know what? I think I'm going to write my divide the old-fashioned way, like that. It'll be easier in the long run. So, and the reason why I'm doing that is because I have a fraction divided by a fraction, and we need to do some manipulation with that, and this looks simpler. So, okay, 2x over x minus 1 divided by, so we're dividing by a fraction, okay? If you recall from previous math courses, when you're dividing by a fraction, that's the same as multiplying by the reciprocal. Okay, I'm going to use a dot instead of x so for multiply so it doesn't look like it's an x. Okay, so now we're multiplying. We got to think back, how do we multiply fractions together? Well, first of all, before we do the multiplying, we would look at if there's any common factors in the numerator with the denominator. Now, the key word there is factors, which means whatever it is needs to be multiplied by everything in the numerator and denominator, you'll notice this x down here and this x up here. This x is being multiplied by the 2, so we're okay. Those are common factors. So we can divide those to equal 1. And we can't divide these x's here this way because it's x minus 3, not x times 3. It's not a factor. So now we can do our multiplying. Multiplying fractions, you multiply the numerators. So that would be 2 times x minus 3. We'll keep that in brackets. And on the bottom, we've got x minus 1 times 1. Now, times 1, I don't need to write that. It will stay the same. Okay, finally, we can multiply out the numerator, 2x minus 6, over x minus 1. All right, we're good. Write an expression in simplest form. I think we've got that. State any restrictions on x. So again, we're concerned with dividing by 0. So let's look at before we canceled off. So this step here, we're dividing here. We're dividing within that fraction. Here, we're dividing within this fraction. But if you go back up to here, we're dividing by this whole thing, which means, oh, that would show up here. So up here, we're also dividing by x minus 3. So those 3 factors I circled need to be set to 0 to figure out our restrictions. Okay, so x minus 3 can't equal 0, x minus 1 can't equal 0, and x can't equal 0. So solve each of these. And these would be our restrictions. Okay, all 3 of them. Essentially, when you're dividing by a rational expression like that, the denominators can't equal 0, but also the denominator from the first step can't equal 0. All right, I do believe that finishes off this lesson, and just to make it a little more exciting, okay, I'll get better music next time. See you in the next lesson.